I just tested the largest rocket motor I've ever built, MEGAx. It produced 1,787 pounds of thrust, which was honestly way more than I expected. This motor took me around 6 months to design and build. During that time, a lot of people kept on asking how much does something like this cost? So I started logging everything: the blast chamber, the test stand, the propellant, and the actual motor itself. Pretty much everything I had to buy for this whole test campaign. In today's video, I'm going through exactly how much a project like this really costs. Starting off with the blast chamber I built. It's basically a reinforced enclosure that lets me safely static fire the motor while containing any debris or failures and protecting everything around it. To dig the hole, I used an excavator, which was $250 to rent. Once the hole was dug, I laid a concrete pad, which the concrete forms cost $25 and the actual concrete itself cost $91. Once the concrete foundation was cured, I used concrete blocks to build up the sides. These were $159, and the mortar that binds them together was $77. I did pay a $75 delivery fee because this stuff was really heavy and it was way easier to get it to my house that way. Finally, for the blast chamber, I had the paint to hopefully waterproof it. If you guys watched the test video, that clearly didn't work, but that paint was $50. Finally, for the blast chamber, I need to build a top to stop rainwater or anything from above from getting in. I don't have any videos of me actually building it, but the plywood was $15. The PVC pipes were $30. The PVC pipes hopefully allowed airflow to stop any mold from growing inside. The pond liner was $20. I used this to cover up the plywood to stop it from rotting or getting bad. And the PVC fittings to hold the pipe vertically were $30. That brings the total cost of the blast chamber to $822. Moving on to the propellant, each cardboard liner for MEGAx cost $20. The top plate was $45, the bottom plate was $20, the finisil was $23, and the PVC coring rod was $10. All these pieces were called the casting hardware, which contained the propellant in the liner while casting. I also used nonstick spray and petroleum jelly to coat the outside of the casting hardware so the propellant wouldn't stick to it. These were $12 and $4 respectively. Finally, the cost of the actual propellant. The potassium nitrate in total cost $56 and the sorbitol cost $43. This brings the total cost of the propellant to $303. Moving on to the test stand, it's a structure that secures the motor and lets me accurately measure thrust, pressure, and temperature during each test. The load cell was $60, the pressure transducer was $37, the T-slot, which I ordered a total of 28 feet, was $230. To connect the T-slot, 190 degree brackets were $30, 100 T-slot nuts were $15, and 100 M8 bolts were $10. The M6 threaded rod I used to secure the motor in place was $16 for 8, and the rod enders were $10. Now looking at the bottom of the test stand, the motor adapter was $108, and the load cell adapter plate was $35. I also spent $50 on a drill bit and tap set, and $15 on miscellaneous hardware. Moving on to the temperature system I built to log the outer casing temperature, which didn't work. The Arduino was $25, the 3 thermocouples were $15, the 3 thermocouple amplifiers were $70, the SD card and shield were $20, and the pipe clamps were $9. Also, the T-slot brackets I used to mount the cables were $16. Also, another thing I forgot to record, but it cost $40 to mount the test stand into the blast chamber. That brings the total cost of the test stand to $811. Now, moving on to the rocket motor itself, the casing cost $84, the bulkhead cost $35, the nozzle cost $90, the nozzle insert cost $35, and the 5 O-rings I purchased to seal the bulkhead and nozzle cost $31. Finally, the MEGAx vinyl decal cost $25, and the radial bolts cost $8. The rocket motor hardware was a total of $308. Moving on to the development hardware, these were extra parts I bought to prototype, take measurements, and make sure everything fit and worked properly before the final build. The casing test cost $20, the O-ring test cost $24, aluminum saw blade cost $25, and O-ring lubricant were $12. Finally, some extra expenses for test day were $35 for plywood, $50 for canopy sides, and $20 for extra cables. With all of that, the total cost for MEGAx's first test campaign comes out to $2,434. Like you just saw, a lot of these things are one-time expenses such as the blast chamber or test stand, so MEGAx V2 will definitely be less expensive. If you'd like to support future builds, get bi-weekly update videos, and behind-the-scenes content, I have channel memberships starting at $1.99. Also, if you're new here, make sure to subscribe because there's a lot more coming with MEGAx V2. Other than that, I hope you enjoyed this video. Please subscribe, comment, and like, and I'll see you guys in the next one.